Good afternoon, ladies and gentlemen. Badger 2 Honors. Good to have you here today. We're going to be doing some exercises with the properties of logarithms, and Steve-O a minute ago asked the question, very good question, what is a logarithm? So what I'm going to do is write a kind of equation. If we have 3 to the power of what is equal to 81. So 3 to the power of x equals 81. Right? Now, we don't know what x is. What a logarithm is, it's the answer to the question 3 raised to the power of what equals 81. That's a logarithm. So we can write it like this: log base 3 of 81 is equal to x. So that's what a logarithm is. So it's an exponential equation written in a different form. So 3 to the power of what equals 81. And what we can do is, who said 4? Yeah, it's 4. And what we can do is we can use a change of base formula or another formula, and the change of base formula is right here, So we can write it like in a calculator. We can just put it as log of 81 divided by log of 3, and we have 4. So that's what it is. So it can help us solve equations, and so that's basically what a logarithm is. Okay, so that was a good question at the beginning of this class.
Then that's what log is. What is IN?
Oh, IN, okay. Well, that's another good question. This right here is LN, and what it stands for is natural logarithm. And the reason that it comes up as LN instead of NL is because it was translated from the French, logarithme naturel, LN. And so in French, they put the adjective after you understand, right, how that works out. So that's where it came from. That's why it's LN. And what they are, and that's a good question, is log. When you see log, this means log base 10. When you see LN, that stands for log base E. Remember the other day we started talking about E a little bit?
Yeah.
So that's what they are. Okay, and we're going to be using these exercises here today, these properties, and working out these exercises here. And, oops, I got it the wrong place. I want to go right to here. There we are. And so what we're going to do is refer back to these exercises and kind of work through a lot of these together today. So right now, we're going to do this one. You have the sum of 2 logarithms, and you can combine them by using this product property of logarithms. Do you see that? I had you take notes on that the other day.
I'm writing that down as students.
Yeah.
Left, right, and we're writing it down.
So that's what they are. Let me go ahead and take attendance while you do that. How did testing go today? The history test. How did it go today?
It's long.
Low. Bailey, is Bailey here today?
Used to, he was MFA.
Okay.
Here, but
Because I think, yeah, I saw her
Didn't
earlier.
they say there was like an FFA meeting or getting the announcements last period.
Oh, they might have, yeah. Jace, you'll be happy to know that I arranged an appointment to get my COVID shot Friday. Are you happy about that? She's not. I'm just teasing you.
So
But I
you're gonna be
did.
here Friday?
No, I will be here. It's after work. I have it. It's done at Brookshire's at 4 o'clock. I'm getting the Johnson & Johnson one, which is one shot.
So how do you like a base and a calculator? Like,
Pardon me?
Can you write a base and a calculator?
What about a calculator?
Can you write a base and a calculator?
Yes, you can. We're going to use the change of base formula, but Steve-O is asking another good question. Steve-O, I don't know what it is about you, Steve-O, that really makes you ask her a good question. We're going to emphasize using the change of base formula, but yes, you can.
Teachers, will you please release all paid FFA members to the cafeteria at this time? Thank you.
Paid FFA members. Maybe that's Bailey, I don't know. So what I'm going to do is I'm going to show, yes.
I just have a question.
Your question about the test here? Okay, just give me just a minute here. What I'm going to do is this first one. So we have what we have is we have the sum of two logarithms with the same base. So we can write this as log base 9, and these two things that are, these two arguments, so it's going to be 12 times 546.75. And then if we put 12 times 546.75, we get 69, 65, 61 equals log base 9 of 65, 61. Well, 9 times 9 is 81. 81 times 9 is 243. 243 times 9 is,
2,187.
what is it?
2,187.
2,187. And then this times 3 should be 6,000, right?
Right.
Equals 65, 61. So you can write this, can't you, as a power of 3? So 3. So cube root of, or 3 to the power of, I don't know what. 3 to the power of 7. Okay, 3 to the power of 8, right?
That's kind of cool.
So 3 to the power of 8. So I can write this as log base 9 of 3 to the power of 8 And then we can use this right here, another property of logarithms, so that'd be 8 log base 9 of 3, and then I thought we had a power of 3. That's going to be to the 9 to the power of what? It's 9 to the power of -1 equals 3. Wait a second. That's 3 squared. I don't. But you can write this as 8 log 3 over log 9 using change of base formula, right? So 8 log 3 divided by log 9. So we get 4. So 4 is our answer to this one. So equals 4. Now, I'm going to show,
How did you enter it in the calculator?
what was that?
How did you enter it in the calculator?
I entered it as a change of base formula. I'll show you where I got the formula from. I got it from right here.
I need new students in the cafeteria.
Because I know.
Alexa Evans, Sierra Green, Jackson Hatcher, Tanner Kilgore, Legend Lee, Nolan Tubb, Kane Widener, Trinity Porter, Carson Renault, Beckett Stewart, and Ryder Calvario.
You do log 12 divided by log 9 plus log.
Oh, no. That's right.
So 5,000 E. So there's 5,000 E. And then we have oops. So there it is. Let's go fix that. All 30,000. Okay, you have a question?
No, I guess I think multiply there, not by that.
Okay, did you work at number 2, I hope? So today, really, a lot of what we're doing today is kind of exploration on what logarithms are, or how to use them. And probably today we're gonna try to get done 1 through 8. Oh, we didn't do this one here. Okay. So this one here, number 2. Did you work out number 2? You have anything for number 2 here? Did you put the calculator right? Okay. Yeah, the idea is to do these without a calculator.
Yeah, all right.
You did that one.
With the calculator.
I just wrote out how I did it.
Oh, really? Okay, that's good. Well, you guys are doing some good work, though. I give you credit for it. Okay, what you're going to do here is this is going to be equal to, this is problem 2 now. It's log base 2 of 76.8 divided by 1.2. And if you put in the calculator 76.8 divided by 1.2, you're going to get 64. So your correct answer is 2 raised to the power of what equals 64? Well, can you write 64 in terms of a power of 2? 64 is 2 to what power? You can just count your fingers, right? 2, 4, 8, 16, 32, 64. So 2 to the what power? 6. Okay, so now we can write this 64 equals 2 to the 6th power. And so I'm just going to go to the right here. So equals log base 2 of 2 to the 6th power. And so we come over to our rules of logarithms here, and using the power property of logarithms, this log base b of m to the n, you take that exponent and you can move it out front. So what we're going to do is we can rewrite this as 6 log base 2 of 2. Well, what's log base 2 of 2? What power do you need to raise 2 to equal 2? 1. So what happens is it's like this cancels out. So log base 2 of 2 is 1. So we end up getting 6 as our correct answer. Right. So what you try to do is get this. If you can get this thing in terms of what the base is, then you can work that out.
Also, instead of just 1.2 times 2 times 2, can you just put in y equals to like 2 to the power x?
You're not understanding a thing?
I'm not understanding this.
Well, the thing about it is we're using all these properties. Okay, and when we're using these, like I explained, I hope, do you understand that this is 64, right? If you divide that, that's 64. Do you understand that 64 can be rewritten as 2 to the 6th power? So then you plunk this 2 to the 6th power in for 64, and using the property of logarithm right here, this property of logarithm is how you get that 6, because remember we had log base 2 of 2 to the 6th. That 6, which is n here, goes right out in front. So that's how you get 6 here. So now you have 6 log base 2 of 2, and then you go back up here. If you have log base b of b, that's 1. So all these are steps that one by one get you from here to here. Because log base 2 of 2 is, and Steve-O was asking about how to do this in the calculator. I'll show you. Log base 2. I'm going to math. And log base 2 of 2 is 1. Okay? So that's the calculator doing it this time.
Okay, then I'm starting to get it a little bit.
Yeah, these things sometimes it really takes, this is not the easiest thing in the world. I grant you that. And I even find myself as a teacher of this year after year, that I have to a lot of times just kind of step back and think, what am I doing here today? Am I going to have clarity enough to talk to Steve-O and explain to Steve-O or whoever in my 7th period Algebra 2 honors class what it is? Some of the things we're learning are not the easiest in the world. All right. So number 3, we have this one right here. And so if we have 3 out front, that's going to be equal to 3 times log of 0.0256, and it's log base 2/5. And I don't know what power of 2/5 this is, but that's to the 4th. I know it's 0.4, 2/5 is 0.4 to the power, I want to say squared to the power of 2. Now we'll multiply that by 0.4 again. So that's going to be 2/5 to the power of 3. And then one more time, 0.4 to the power of 4. That's it, right? So this is 2/5 to the power of 4, 0.0256 equals 2/5 to the power of 4. Is that right? That's right. So what we have now is 3 log 2/5, a log of 2/5 to the power of 4. And what do we do now? Okay, we're
Or
not.
you bring it,
4 times 3 is 12.
yeah.
So now we have 12 log base 2/5 of 2/5. What's the log base 2/5 of 2/5?
Wasn't it?
That's 1.
1, yeah.
So our answer here is going to be 12. So what I did is I had to experiment with that 2/5 to kind of see, because I knew if this is going to be simplifiable, that 0.0256 is going to have to be some power of that. So basically, I had to figure out, I know what the textbook is probably trying to do to us. So I had to do a little mind reading here, didn't I? Was I able to do a little mind reading? Yeah, and I was not able to do this 2nd period today. But 7th period today I am. So am I getting smarter as the day goes on? No. Probably not, but I'm getting more experienced. No, I'm not getting smarter. Chris, you're right about the thing, Jason. Okay. So to me, that was maybe the least straightforward of the ones we have today. Why don't you do number 4?
I don't like number 4.
You don't like number 4?
I don't like number 4.
You don't? I like number 4. I like number 4 better than number 3 and better than number 1. Number 2 I like pretty well. But I like number 4 better than number 1 or number 3.
Well, I probably despise number 4. I haven't looked at the other ones yet, so I'll probably get them.
Is 23 just your unfavorite number? Yeah, Michael Jordan's number. You just don't like Michael Jordan?
I don't pay attention to basketball.
Oh my
Okay, Jason doesn't know he's a
I'm
basketball
doing
player.
something so stupid.
Oh no, I pay enough attention to Jordan's shoes.
Jordan's the shoes.
Because they've got a basketball player on it.
I'm so confused.
So Luke, you do some of your artwork on Jordans?
Yeah,
Yeah.
I do sometimes.
I heard the other day that the Michael Jordan brand of Nikes outsells all the other brands put together.
Or Air Force.
Yeah. That's how popular that is.
So,
Oh wait, a hat.
how do
Maybe.
you know which
Mr.
number
James.
goes into the square, and how do you know which number is the one being divided?
Those two are out.
Oh, okay. I know what you're saying. Yeah, that's probably not.
Like,
Well, this one right here, in number 4, what do you do with this 23?
you put in the front.
So you got 23 log base 11 of 11.
The last one.
What's log base 11 of 11? 1, right? So this is 23. So that is our answer to number 4. 23.
I was just confused. Are you kidding me? Mrs. I don't like this corner. I don't like this chapter.
You don't like chapters?
Oh.
You're gonna dislike the next ones. They have excellent work.
Well, here's the
I'm
thing
sorry,
about
you did what now?
you know that we're gonna move on from this, right?
Oh.
And you know that you're gonna be graduating soon, right?
Gee.
I don't know if I've ever had somebody get this much of a reaction to logarithms
Seeing that,
before.
then him doing that just tell me off. Just whatever.
So,
I don't wanna.
okay, number 5. Does anybody, does,
Did you know?
I know that
I think I might have found out another way to do this type of problem.
oh, really?
Because I can figure out how we did it, so I just figured out something.
Okay, cool.
I won't say too loud.
Yeah, thanks. I appreciate that. Good job. So you're talking about these problems here, Luke?
Now I'm saying on our guide, I couldn't figure out how we did it, so I started messing around with the
Or the
numbers.
study guide?
Yeah, I was messing
Okay.
around with the numbers and I got the right answer.
Okay. All right.
So,
All right, you have an idea on how to work out number 5?
No,
I lost the
people.
The X throws you off?
Okay.
Okay.
I lost the people for exponent, like the people that has on the floor, so I don't.
In the words of my mother, letters do not belong in math.
Letters do not belong in math.
No, math is numbers.
Math is numbers. Well, here's the thing about it. And I saw this Facebook theme meme or whatever it was a long time ago. It says, and then Satan introduced letters to math. And so is that what your mom was saying? Right? Well, here's the thing about it. Until Satan introduced letters to math, we were not able to have an advanced civilization. It's the advanced civilization. You see Rene Descartes over there? He's one of the first pioneers of it. And he invented the XY coordinate plane. I told you about that, didn't I?
Yes.
Yeah, he invented the XY coordinate plane. And then when we had that, we were able to, shortly after that, you had Isaac Newton in calculus, and Leibniz in calculus. And so many things became possible once we were able to have the concept of variables for unknowns, which we use. And so we may not like it when we're having trouble with algebra, but these things that we have trouble with are the things that have made 21st century conveniences possible. Okay, including driving car, whatever it is that makes our life convenient. It's those letters that made it possible.
No, it's awesome.
Yeah, I understand that. So you don't like them, but you use them whether or not you like them. Okay, this one right here.
That's my brother.
No, but,
I don't like him, but unfortunately I need him.
yeah, right. What you have here is you have this x plus 1 in the power of the exponent. So what this is going to be equal to is x plus 1 times log base 5 of 5. Okay, so everybody see that? And then we have plus log base 4. And can we rewrite 256 as the power of 4? Four to what power is 256? Well, we know 4 squared is 16. 4 cubed is 64. And what's 4 to the 4th power? 256.
You could just,
So we can rewrite this 256 as 4 to the 4th power, and then we have outside of that this 2. Do you see that? So this 2 comes here, and so now what we have is log base 5 of 5 cancel each other. So we have x plus 1, because that cancels out to become 1. And then we have plus log base 4 of 4 to the 2 times 4, 4 to the 8th. So what we have is x plus 1 plus 8 log base 4 of 4. What's log base 4 of 4? 1.
So it's x plus 1 plus 8?
Yeah, so you have, so what you have is x plus 1 plus 8 equals x plus 9. So all this here simplifies to x plus 9.
I can take it 5 over 5. Oh wait, I didn't notice the small 5. Never mind.
Yeah, that's where it came from.
Yeah, I didn't notice it.
No, that's fine. That's cool.
Yes, I don't like it.
What's that?
I still don't like
You
it.
still don't like it. You don't really have to like it. You don't have to like it. You just kind of stay with it and get through it. You're going to be okay.
I'm able to stay with it. It's just-
Abigail, you're going to be okay, Abigail.
It's
Are
like
you
the,
sure?
You'll be okay. It's going to be
I feel
okay.
like I'm gonna end up going through the steps of grief.
Wait.
it's like going over to a friend's house and they give you food and you don't want to be nice and eat it, but the food's really bad, but you eat it anyways.
Oh, at that point in time, I say I'm on a special diet and can't partake in it.
Oh, this is a good class. This is a good class today. I like the conflict, the conflict and conflict resolution or unresolution. This is a really good class today. Okay. And even with Bailey gone today, it's a good class. All right. Anybody try number 6 at all yet?
Nope.
Are you kidding? Okay. Number 6, what we have is log, and we're talking about, we see log like that, that means log base 10, so I'll just write that here. And then we have is this is going to be log base 7 using the quotient property of 98 divided by 2.
Those are going to be super easy.
Okay, and then we have x up here like this. All right? Are we okay to, you know which property we use for this, right?
Yeah.
The quotient property. Okay? Okay, what are we going to do with this x over here?
Put it behind the log.
Yeah, so what we're going to do is this x will come over here. So it's going to be equal to x log base 10 of log base 7 And what's 98 divided by 2? 49, right? Can we write 49 as the power of 7?
Yes.
Yes.
So that's going to be 7 what? Squared. So we have log base 7 of 7 squared. What do you do with this squared thing?
Put it outside.
Right over here. So it's going to equal 2x log base 10 of log base 7 of 7. What's log base 7 of 7? 1.
So the log,
It would be 2x log 10.
So what we have, that's going to be equal to 2x, and we have log base 10 of 1. So what is log base 10 of 1? It is 0. This simplifies to 0. So if this is 0, what's this whole thing worth here? 0. Okay? So this whole thing, this whole complicated looking thing here simplifies to 0.
That's crazy.
Mr. D, I did it.
You did it?
I did it.
See, that's success. So Abigail has been frustrated with these all day long.
I'll just say equals 0.
Well, here, I'll tell you how it equals 0. 10 to the power of what equals 1?
1.
Let me show you. 10 to the power of 0
oh yeah.
equals 1.
Yeah.
So therefore, 0 is the answer to the logarithm of 1.
And every time 0 equals 0.
Yeah.
Every time 0 equals 0.
Right.
0.
That's right, huh? Zero factor properties.
That makes sense.
Okay.
It's starting to make more sense now.
Yeah, started to make more sense, okay? I want you to look at, let's just go to number 7 here today. And do you have an idea of what to do in number 7?
Maybe. They're moving these very old.
What does the 3 do first?
Goes in front of the log.
So 3 goes here for height, so you get log base x plus 1,
I'm not sure what to do with the other part though.
and then
Simplify x squared.
then this one's going to be what? X plus 1 squared. So then we have 2 times 3 or 6 log base x plus 1 of x plus 1. What's this going to be? What's this going to be?
1.
1.
So B for the answer.
Answer 6. So we'll just leave it there today. Come back tomorrow. Thank you.
This makes very more sense now.
Okay,
Yeah.
I figured it out, Mr. D.
Very good. So light shining.
I'm gonna forget this
Come.
all over.
No, you will, and I promise you, I have to do this too. When I come back to logarithms, I have to refresh myself too. So I don't blame you a bit for how
Thank
you
you for
feel.
having patience with my.
No, you have, no, it was good. It was entertaining class today. It was really good. Thank you for.
I'm glad